Glad you guys could all be here. I do see a few new faces, and I see some familiar faces, and I see some people, at least a couple of people that were here when I gave this talk last year at a joint meetup with Learn to Code. So that means you either liked it or you fell asleep and missed it and wanted to see what I talked about. Either way, I think that's good. Anyway, for those who haven't been to a meetup here with Santa Barbara JavaScript, we are obviously a group of JavaScript enthusiasts. We have varying skill levels that come to these things. Everything from brand new people that have never looked at a line of JavaScript to old farts like me who have been doing it for longer than we'd like to admit. But we are very much a community of learning and mentoring. We want people to come here and ask questions. We want people to come here and teach others. I firmly believe that experiential learning is the best way to learn. Mentoring others and getting your hands on, getting dirty with the code. And so we have a variety of events that we have planned, but our regular monthly meetup like this is typically somebody will come up here and speak, show some code. And we've had a few where we've done interactive coding experiences, and I think those were received pretty well. We'd love to do more of that kind of thing. I know that my co-organizer Garvin and John over here that runs Learn to Code Santa Barbara are starting another project which is going to be hands-on coding. John, I think, is going to talk about that a little bit later. But anyway, the whole idea here is this is your meetup. This is not my meetup. So I want you guys to give me ideas for what you'd like to see us do, what you'd like to see us do better. I think it's the best meetup in town, but I'm biased. But with your help, we certainly can. That said, tonight's an encore presentation. After that, I got nothing. I have no speakers for the next few months. And that means that I need people to get up here and speak. So there's nothing off limits as long as it relates to JavaScript. If you're programming knitting machines or something to feed your cat with JavaScript, we want to hear about it, right? No topic is out of bounds, and you don't have to be an expert either. Another great way to learn about something is to teach others. So a couple of years ago, I gave a 3-part series on ECMAScript 2015 or ES6 because I was really curious about it. I've been following the spec for a while. And I figured the best way that I could polish my knowledge of it was to put together a 3-part in-depth series and teach people about it. And lo and behold, I learned quite a bit about ES6. So if there's some topic out there, it's really hard to find time for extracurricular learning when we have 9-to-5 jobs, right? Unless your employer is really cool and gives you time to play, right, and do R&D stuff, it's really hard to find the time, especially as you get older and you have kids and responsibilities and mortgages and shit like that. So this is a great opportunity to do that. If there's some topic that you've been meaning to learn, if you want to learn about Preact, which is the super streamlined version of React out now, or Redux or reactive programming or observables or something like that, I want to learn about those things too. So learn about it, put a talk together, talk to one of us, we'll get you on the calendar, right? Sound good? All right, cool. Some housekeeping stuff. I want to thank our sponsors. We've got WorkZones, which is where we are tonight. Thanks to WorkZones. So WorkZones provides us with hosting on a pretty regular basis, and they are a co-working space. They offer meeting space, and if anyone's interested in checking out their facility, we can hook you up with a guest pass. I'm sorry, what was your name again? Neil. See Neil, and he'll set you up with a guest pass. You can come out and see what they do, and if you're interested, you can sign up. But we're very grateful to WorkZones for hosting us. My employer, Agilicis, has been a sponsor since I started running this thing, and they provided the pizza tonight. So yeah, Agilicis. I was mentioning to a couple of folks tonight, Agilicis is on the cusp of a major expansion into the international market, and we're about to ramp up hiring pretty significantly. I think early on, a lot of that stuff's going to be offshoring. We're actually going to build up a team of employees that we employ in Chennai, India. But after that, we're probably going to be looking to ramp up pretty significantly. Most of the jobs here in Santa Barbara are going to be on the Microsoft stack, .NET, things like that. But there will be opportunities for JavaScript developers. Node is something that I'm aggressively pushing into the stack. So if any of that kind of stuff interests you, talk to me, and we'll see if we can't squeeze you in there somehow. PayJunction became a sponsor of ours last year. They've hosted a couple of great events for us. They provide hosting and food, and we're going to try and get them to provide some speakers one of these days too. So that goes for all you two, all your employers, right? If you have people that are like JavaScript whizzes, you guys in the back with InTouch and anyone else, we need people to speak. And then lastly, we have a partner program with O'Reilly Media, and that gives us discounts on books and videos and educational materials. And the cool thing is it gives us a 20% discount on conference passes. And if we use that 3 times, I get a free conference pass. No, I'll raffle it off, or somebody here will get it, right? And that's kind of a cool thing to have. All right, so with that stuff out of the way, who am I? Well, my name's Tim Doherty. I've been running this thing for about 2.5 years now, something like that. I'm a software architect at Agilicis. It's a good gig. I started there as a senior engineer, and pushed a lot of really cool JavaScript things in the door, like Angular and Node and Grunt and Yeoman and all that kind of stuff like that. And they liked it so much, they made me a principal engineer, and then they made me an architect. So I don't get to code anymore very much, which is really kind of a drag. But I do have other interesting challenges, and now I'm trying to pass the baton onto some of the UI leads to keep the fight going with the things that I started there. I obviously also organize Santa Barbara JavaScript, and I'm also the vice president of Paradise Dive Club. I'll be the president in September. What does that have to do with JavaScript? Absolutely nothing, but it's really cool. The diving off the coast here is pretty spectacular. There's my social media stuff, my blog that I never update, so you guys could prod me to update that as well. All right, so to start out, this is a talk on object-oriented JavaScript. So raise your hands, how many of you think JavaScript is an object-oriented programming language?
Is or is not?
Is. Okay, we've got a few hands. That's good. Most people say no, right? Just off the bat. They say JavaScript is not an object-oriented programming language. So I'm going to disagree with that sentiment and say that it is. But we're going to talk about what do we mean by object-oriented programming language. Because I think most people are confused by that term. And it's evolved, certainly has evolved drastically since it was first coined. And what people think of as object-oriented programming today is quite a bit different than what Dr. Alan Kay thought of when he first coined the term. So let's start with this wonderful quote from Dr. Alan Kay. How many people don't know who Alan Kay is? Okay, most of you know. He was a computer scientist, American computer scientist, and he is famous for leading the team that invented the Smalltalk programming language back in the 60s at Park. And he's the guy that first coined the term object-oriented programming. And he was responding to a PhD student back in 2003, well after Java had become mainstream, asking him in response to a question about what did he mean by object-oriented programming? And what he meant was this very simple definition here. And his opinion was that only Smalltalk and Lisp can do it as of 2003. So what he meant by object-oriented programming bears little resemblance to mainstream classical object-oriented programming today with languages like Java, right? So it's interesting. I had this discussion with some colleagues a few years back, and I was like, tell me why. What is object-oriented programming? And today, what we mostly think of, the three sort of pillars of object-oriented programming are inheritance, encapsulation, and polymorphism, right? There's a few other things like message passing and dynamic dispatching and things like that, but those three are kind of the pillars of it. So JavaScript is a multi-paradigm language. It doesn't embrace only one paradigm. It's got a couple of them, right? It has good old-fashioned procedural, just statements executed in order, right? It's got an object-oriented paradigm, but it is not mainstream class-based object-oriented programming. It's in fact prototypal object-oriented programming. And then it also embraces a lot of concepts from functional programming, things like pure functions, functors, right? Lambda expressions and things like that. And while it's entirely possible to use just one of those paradigms, if you look at the typical JavaScript code base, you're probably going to find a hybrid. You probably find a little bit of all of three of those paradigms in your average JavaScript code base. But I'm going to argue that in addition to having the three pillars, the inheritance, the encapsulation, the polymorphism, and a lot of the other things that we associate with modern object-oriented paradigms, in the sense that everything except a handful of primitives is an object, and that objects inherit directly from other objects and delegate directly to other objects without the abstraction of a template or a class, that JavaScript is more object-oriented than a lot of mainstream class-based object-oriented languages. So what do we mean by an object in JavaScript? It's basically a really simplistic idea. It's a map. It's a dictionary, right? It's just a sort of a bag of key value pairs. It's really all it is. There's no idea of accessibility modifiers. Properties and methods can be directly accessed by other objects, right? You can directly manipulate other objects' state, although there are ways of encapsulating that state, and we'll look at that a little bit later. The constructors are entirely optional, and so are prototypes, although there's a caveat to the prototype thing. We'll get to that when we talk about prototypes. So the simplest way, and this was introduced in ES5, ECMAScript 5, around 2009, of creating objects is with this object literal notation. And it looks just like this. You have a curly bracket and a bunch of key colon value. And that value can be a string, it can be a function, it can be a number, it can be null, it can be undefined. Any of the primitive types or and by the functions are objects in JavaScript, right? You have a handful of primitive types, everything else is an object. So this is a really simple way to create an object. And here we say without constructors or prototypes. There's a caveat there. By default, all objects have the object prototype as their prototype, object.prototype. You can optionally use constructors to couple your instantiation and your initialization of objects. They're entirely optional. There's no default. There's no special ceremony or syntax, although the community has embraced the only place in the syntax that you capitalize things is the constructor function. It's not enforced by parsers or compilers. But because they're just functions, there is a special syntax requirement for creating instances, and that's use the new keyword before them. If you just call a constructor, you'll get a syntax error, typically. Because, if it references this inside the constructor for instantiation or initialization of that object, chances are you'll be doing it in a lexical scope that doesn't make sense, and like a window or something like that, and it'll probably fail. So this is what it looks like. It's just a function. Notice we capitalize the M. That's just a convention. It means nothing to the parser or the compiler. Inside it, we're going to set an initialization variable. We're going to set an instance member. We're going to call it foo. We're going to instantiate it with the new keyword, and then we can directly reference without any ceremony. There's no getters or setters required. They're optional. We'll look at those. Okay, prototypes. Everybody understands prototypes, right? It's the clearest, simplest thing to understand in JavaScript, right? We all understand that. That's most people's luck when they try to explain prototypes. But there's really no magic around prototypes. Prototypes are actually fairly simple once you grok them. It's just that the syntax for constructors and prototype chains is a little clunky, and there aren't a lot of really good explanations out there. But they're actually, once you understand how they work, they're fairly simple. They're a little odd, and they're certainly out of the mainstream. JavaScript isn't the only prototypal-based language, but it's by far the most mainstream. But a prototype is just not. That's all it is. It's just another object. And the only thing that makes it a prototype is that another object says it's its prototype. And all it's doing is saying, I don't have this behavior. I want you to execute the behavior and pretend you're me, essentially. That's all it is, right? It's delegation of behavior. The prototypes are optional, with the exception that if you don't specify one, an object gets the default objects, built-in objects prototype. And once an instance is created that points to a prototype, changes to that prototype affect all instances. So it's extreme late binding, right? What Dr. Alan Kay was referring to. There's a note down here. Instead of classes, we have prototypes. For those who's not familiar with ES6 or ECMAScript 2015, this spec's about 1.5 years old now, so most people are familiar with it. They introduced class syntax, but it has nothing to do with classes as we know them in class-based languages. It's probably the only controversial feature about ES6, and we'll talk a little bit more about it when we look at the class syntax. So this is what a simple object with a one-level deep prototype chain looks like, right? We have our constructor function that we saw before, and we're initializing it with a foo member, and then we're going to set a method on its prototype. And all this means, this is just a special keyword that says, I'm pointing to another object. And when we do this, the minute we attach a method to it, it's essentially is creating a new object for us and substituting that for object.prototype. And so this is basically saying, here's my object. I have a relationship with some other object, which is just, I'm going to point at it and call it my prototype. And that's the only thing that makes it a prototype, is that some other object calls it one. And we're going to attach a method to it called bar. So we make an instance from our constructor. And we know we have this instance member foo. We should be able to access that, right? But we can also call bar. And the way we call bar is the instance says, do I have a method called bar? No. Do I have a prototype? Yes. Does that prototype have a method called bar? Yes, call it, right? Et cetera, ad nauseum, for as far as the prototype chain goes, until it reaches a point where there's no more prototypes. And then it'll throw an error, right? It's actually fairly simple. The other thing is, after we've created that instance that we created on the previous slide, we can now modify the prototype. We're going to add another method called baz, and now every instance that's already been created gets baz. It's kind of cool. There aren't that many legitimate use cases for it, but there are some. So another cool syntax we got in ES5 was object.create. So Object.create helps alleviate a little bit of that clunky syntax that we saw with constructors and prototype chains. And basically what it does is it gives you the ability to create objects with or without prototypes and with or without constructors. So if you call it, the first argument is the prototype that you wish to use. You're saying, create me an object, and here's its prototype. If you create it with undefined, that object literally has no prototype. I mentioned before that the default prototype is object.prototype. This object will have no prototype. So if you try and reference its prototype, you should get a runtime error. You can optionally pass it a hash of property descriptors, an object that defines the properties that that new object instance will have. And the cool thing about this syntax is, as of ES5, ES5, I'm going to digress for a second. Who's familiar with the history of JavaScript, the versions of JavaScript? Who's totally unfamiliar with it? That's what I'm looking for. Everybody's familiar with it?
No, I'm unfamiliar.
Okay, so. Okay, so obviously it started out with ES1. ES2 was basically just there were a couple of housekeeping things for it. ES3 introduced a few interesting things, and off the top of my head, I can't remember the feature list, but it was a fairly small update. Then the TC39 committee at ECMA went off and tried to come up with this really bold and ambitious plan for ES4. And some of those features made their way into ES6. But what happened was that the committee split. You had some of them saying you're going too big, you're trying to add way too much to this, what is basically a simple scripting language. And you had others saying, no, we need to bring this on par with other modern, contemporary, capable languages. And they ended up with a rift, and they couldn't see eye to eye for quite a while. And the release of ES4 got delayed and delayed and delayed. And eventually what happened was they met, I think, in Oslo, and they finally reached an agreement. They shook hands across the table, and they were in Harmony. And so for a while, we had this code name release called Harmony, which ended up being ES6. But in the meantime, they did agree on a really small subset of features that they thought were important to the language, that both sides, the conservatives and the really ambitious sort of visionary people on the committee. And that ended up as ES5, which was sort of a compromise between the bold vision and the not so bold vision. And as such, my opinion is just about everything in that moderate release of ES5 is important to the language. And one broad category of things we got in ES5 were these object reflection methods that allow us to define properties and define metadata on those properties. And so the cool thing about this hash of values here is you don't just get to describe the key and the value of properties, you get to describe things like whether or not it's enumerable, whether you can see it when iterating through the properties, whether it's writable or not, right? There's a variety of really interesting things you can do. And it also allows you to do, with related methods like object.defineProperty, you can do really cool things like write your own proxy, right? So ES6 came out with a proxy implementation that basically sort of like traps in an operating system, where you can define how outside access makes it through to the underlying state of the object and do things like bounce it back or do intermediate processing and things like that. You can actually do that with ES5. You just enumerate through an object's properties and then expose another object that defines getters or setters appropriately on top of that, and then you can block outside access or do intermediate processing, like go to a database, cool stuff like that. So that's the second argument, is just a hash of properties. So here, with object.create, we're actually just going to give it an object. Remember I said before, prototype's just an object? We're going to create a new object, and that object's prototype is just going to be this plain old object literal here. And then here we're doing both. We give it an object as a prototype, and then we define instance properties on top of that. So object.create is kind of a really nice way of doing things. You don't have to have this clunky looking, constructor.prototype.method equals. You can actually have a clean inline literal syntax for defining it. And so one of the ways you might use that would be to define an object factory, right? And so this object factory has the prototype defined inside it, which is sort of like encapsulation of that private member variable. And then you're just going to basically pass in a hash of props, use that prototype, and return the results of object.create, right? I think that's actually a little cleaner than using constructors and setting up the prototype chain that way. But that's just my opinion. I just think it's a cleaner way of doing it. So a hybrid approach might be to use the constructor and the prototype chain, and then use object.create to specify the prototype, and then just call the constructor on itself. Is it useful? I don't know, but you can do it, right? One of the things about this language is that it is fairly non-prescriptive. JavaScript comes complete with lots of foot guns, much in the way that Ruby does. And it's very easy to shoot yourself in the foot if you don't know what you're doing. And there's also a variety of different ways at times to achieve the same results. And so this is more or less just illustrating that you can do it. I'm not saying that you should. If you use this code and someone yells at you, don't tell them I told you, okay? Okay, classes. I mentioned classes, right? And I mentioned that they are probably, I think most people would agree that have spent any time looking at it, that it's really the only controversial feature in ES6. There's a lot of features that people are like, little syntax trick. Did we really need the Unicode changes and things like that? Arguable. But classes really stirred up a lot of controversy, and it hasn't died down a whole lot, although they have been widely adopted. How many are using classes? Anyone using classes in their code base? How many are vehemently opposed to them? How many people just don't give a shit?
Slightly.
So they were introduced in ES6, and like I said, they're controversial. And what they really are, they're not classes. They're not classes as we know them from class-based object-oriented languages. They're not templates. It's just syntactic sugar. Underneath the hood, it's just that classical syntax that I should not use the word classical. It's the old-fashioned syntax we saw from ES5 and earlier of constructors and prototype chains, just wrapped up in a sugary new syntax that looks like classes, but doesn't behave that way. And so the main argument for them was that the two main arguments. One was they wanted to attract class-based OO developers, and they thought that that syntax would make it more approachable. And that has turned out to be pretty true. And we actually, during the ES6 three-part series I did, after the talks, I set up a bunch of empty unit tests, failing unit tests with Jest and some examples. A guy there, and it was beautiful because he goes, "That's not how this works." We had a class, right, and binding the lexical scoping of this changes. He goes, "That's not how this works." As we were going through the talks, he's like, "Oh, classes, I know classes. Yeah, this is great. That's not how this works." So, so that's one of the selling points that the committee made. And the other is, and this one I sort of buy into, there's a whole bunch of libraries out there prior to ES6 that were trying to shoehorn the classical OO paradigm on top of prototypal inheritance anyway, like React. Right, React.createClass. Anyone seen that prior to the JSS syntax? Well, TypeScript was TypeScript's a little. It's similar, yeah, similar. It's slightly different because it actually does introduce. Yeah.
It's more like PHP.
Yeah, and it's imposing an optional type system on top of JavaScript. So definitely related, right? But there were a variety of libraries out there doing it in different ways. And so the thought was, if the community is doing it anyway, why don't we standardize the syntax? It makes it easier to write tools. It makes it easier to write refactoring tools for IDEs, parsers, all that stuff like that if the syntax is standardized. And so I sort of buy that. The problem is that, just as I said with the Java guy that came to the coding exercises, that same syntax that initially looks really friendly to them trips them up because they don't know what's going on under the hood, and the syntax is very different from the semantics underneath, right? And then, that makes those very same OO developers go, JavaScript is bullshit, right? I get in flame wars all the time. So we're a Java shop at work. All our services are Java, on my team anyway. And I have nothing against Java. If there was a perfect language, we wouldn't have so many, or we'd all be using Lisp or something like that, right? But the reality is that all languages have good stuff, and all languages have bad stuff. I like to tease the Java guys because it's super verbose. I actually sent a great example out the other day it was for like medieval warfare, right? So first they had the no nails, throw a no new nails found exception. And then it was like a writer, right? Battle factory dot missing persons dot constructor for writer prefigure confider dot new writer dot dispatch dot battle dot find, right? You guys have all seen Java code. It can be very verbose, right? All languages have problems. JavaScript's got a bunch of them. I'll be the first to agree with an informed criticism of JavaScript because there's lots of stuff to make fun of and lots of weird decisions that were made and quirks in the language. But what I can't abide by is people just saying, language X sucks. Okay, why? Don't just tell me it sucks. Give me some sort of advice. And so the danger there, of course, is that the class-based, the Java guys go, JavaScript sucks. See, I told you it sucks. Anyway, I got in a flame war today with guys and said the same thing. One of the guys was trolling me about my stance on object-oriented programming. And I was like, okay. And I gave him the same argument. I was like, what is it, object-oriented programming? Here's what Alan Kay said. Here's all the things we consider as object-oriented programming today. And I enumerated them, no response. And I was like, come on, I'm looking for the informed criticism. And then I did like a Slack Jiffy crickets chirping. There's the huge list of informed criticisms. I can't resist it. It's just too fun sometimes. So this is what the syntax looks like, right? You have this nice little syntactic sugar that says, define your class name. You define a constructor function. And this, by the way, is exactly the same as doing function myObject, right? And putting that initialization code in there. And then you define your prototype methods in line, right? You can also define static methods, which would be the same thing as attaching a method to this constructor function object, because functions are object. So the syntax maps all the way back one-to-one with what we've been doing in ES5 and before. It's just, I agree that it's actually kind of nicer. The syntax is cleaner. And I do think that the old-fashioned constructors and prototype chain syntax is a little clunky. I just wish they could have figured out something better to call them than classes, because they're not classes, right? Anyway, that's what it looks like. Okay, so I talked about property access. So JavaScript has no concept of access modifiers. Everything's public, essentially, right? But there are ways around that. We'll look at that when we get into encapsulation. But basically, the ways you can access properties is either directly with the dot notation. You can access them via brackets. And starting in ES6, with that brackets notation, you can use computed property names. Just a little cleaner to do inline if you're doing object literals, rather than creating the literal object and then defining those properties afterwards as computed properties. You can do it inline actually now with the object literals, which is kind of nice. This is my all-time favorite quote about JavaScript. How many people have ever felt that when working with JavaScript? I don't anymore, right? That's only because I took the time to learn how it works. And it turns out, so there's this thing, right? If you're ever wondering how things work in JavaScript, there's this thing called the specification. It's just fantastic reading. It's a page turner. If you ever want to fall asleep at night, pick up the spec and read it. But the beauty of it is that while it's verbose and boring and dry, if you're ever wondering how something is supposed to work, how the browsers are supposed to implement a particular language feature, the spec will tell you in absolutely unambiguous terms. And there's a great little spot on how this is resolved during any function call or any piece of procedural code. It'll tell you the exact rules for how this is identified by the compiler and by the runtime, right? And it turns out that once you understand that, it gets a lot easier to reason about your code. In addition to that, there's some fantastic tools available natively in the language that let you manipulate the value of this. Things like function.call, function.apply, function.bind, things like that. And now in ES6, we get arrow functions, which one of the use cases for arrow functions is they don't create a new lexical scope for the function, which means that the outside lexical scope, the value of this, pertains in the function body. So there's pros and cons to that. Lots of other uses for arrow functions. They're terser, right? There's a few other use cases. They're really cool, but you shouldn't use them everywhere.
There's like let.
What's that?
There's let.
Yeah, but let won't affect context. The only thing, let is a block scoped declaration, right? Which means that it's only available from the line which is declared below, and it doesn't get hoisted, right?
I don't know, like in my mind, like, let next to a clear, like, you won't be messing with this.
Sure. Maybe. So I'm in the middle of a war with one of our contractors. And so you guys stop me if I digress too much. And I do want to get through the slideshow, but I love to like digress and talk about stuff. This is being recorded, so I probably shouldn't use that word. My colleagues are going to watch this. Some of them may actually be watching it on YouTube right now. That's all right. I swear there too. Anyway, we all know now based on scientific studies that people who curse are more honest, right? So that means I'm pretty honest. So anyway, I'm in the middle of a flame war with one of our contractors. So I'm of the opinion that contractors bring to the table skills for which we pay them, and so we should respect their expertise and opinions, and it's always welcomed and helpful. But at the same time, I'm wary of contractors influencing coding styles, because contractors come and go, but the core team of full-time engineers will be there longer term and needs then to be able to pass that coding style on to new employees and contractors. And so it's really important that the core team is responsible and makes the decisions about the coding standards. And one of the things that ever since ES5, I see very few legitimate use cases for this whole var self equals this thing that we used to have to do, that function, that underscore.bind came along to solve, right? Right, there are very few legitimate use cases for it anymore. Now, people will argue that it's conceptually easier to understand than function.prototype.bind. I don't buy that argument either. You know, I think that, and this goes back to my statement about the additions in ES5 all being important ones. They were very carefully considered. This was a compromise that people thought were the really important features that ought to make it into the language. And it's really a cousin to function.prototype.call and .apply, right? Which also let you specify what the context of the inner function is, right? Bind, it lets you do things ahead of time. It lets you create a new function with a pre-bound this inside it. I think that's a lot clearer than setting a variable in some lexical scope that bleeds and creates side effects in sub-methods, right? I mean, if you're talking about a method, right, on an object, to a certain extent, all of those methods have side effects, because if they refer to this, then instantly they've got a side effect. They're not pure functions. However, by using function.prototype.bind to refer to that lexical this, you constrain the side effects, right? It makes it easier to test. They're purer. I also personally think the syntax is cleaner and simpler. And the other thing people often fail to understand or know about function.prototype.bind is, in addition to binding the context, you can also pre-bind arguments to the function. So it makes currying and partial applications of functions super simple, right? The first argument is whatever this should be, and the subsequent arguments are arguments that should be pre-bound to that function when it's called. So I have a new contractor in who is adamant that we should replace all these function.bind calls with var self equals this. And I'm trying to let him make his argument for it because I want to hear it. But I think, honestly, I think the only place that really makes sense is when you need to refer to both lexical contexts. So a great example is a jQuery callback, right? When a jQuery callback enters its function, this by default is bound to whatever that jQuery matched set is, right? So if you're bound to, say, an input box, right, and you call a jQuery method on that, what you get back is that match set that matches the input box. You may want to use that, right, without having to reselect it. It makes sense. I get that. And you may also be inside the method of an object, and you want to refer to what it thinks is it, right? The lexical binding of that object. That's really one of the few use cases I can see where it makes sense to predefine this in that method as some other variable that sits outside in a closure, essentially, and then allow that lexical scope of the callback to also refer to its own this. Otherwise, function.bind really makes sense everywhere else.
Question, like, you know, in your style guide, how do you deal with the namespace? Like the namespace
We don't. No, we are 99.9% converted to a module system, and so namespaces we don't care anymore. We have fully qualified namespaces that export named functions and things like that. We still have a little work to go in there, but all ES6 modules, except for some third-party dependencies that get transformed into common JS modules. Anyone use JSPM? That's been our latest endeavor. I'm gonna put a talk together on that. I submitted a bunch of talks for Fluent this year. We'll see if any of them get accepted, and if they do, then I'll dry run them on you guys. Last thing on function.prototype.bind, because I had to say this. So a lot of the criticisms for it, the criticisms are generally of two kinds. The first is that it's too hard to understand. Bullshit. If you can't take the time to learn it, don't tell me that it's too hard to understand. Guess what? Computer programming is hard. Software engineering is hard, right? I mean, seriously, like, don't come to me and tell me that this is too hard to understand if you haven't taken the time to learn how to use it. The feature's been around since 2009. So it's widespread, it's readily available, the documentation is really good. That's the one category. And the other category is the pitfalls that people can fall into if they don't know how to use it properly, right? So for example, don't call .bind in a loop. It's expensive, right? Or, if you don't understand that you can pre-bind arguments, then don't expose those aliased pre-bound functions to people without telling them that it's pre-bound, right? You should use descriptive names like curried function, left-hand side single curried function, a version of this function, right? You make your intent explicit. However, the bottom line is poor usage of a feature does not equal a poor feature. And so, I'm pushing back on this guy, and I'm trying to give him an opportunity to make his point while also saying, look, you give me a valid use case, and I'm all for it. Otherwise, This is what we do, and there's good reason behind it, and this is why. Yeah, John.
Do you happen to have code snippets that you can show us there's sort of the two together?
No, because this is more about, this is just a tangential thing. I went off on a tangent about this, and we will look just briefly at what this means, sort of, and how you borrow it. But if you're interested in that, I can certainly talk to you offline about it. Yeah. We could probably do a whole session on function.prototype.bind. But anyway, as we all know, the value of this changes depending upon where the code is being executed, where the code has been invoked from is really what's the most important thing. And depending on, so for example, if it's procedural code, right? In other words, if it's not encapsulated within a function, if it's not a method of an object, this will always refer to the global object, which in the case of the browser is the window, right? If it is within a method of an object, this will always refer to that object if the method is called directly on that object. And then there's a variety of behaviors from there. But what this allows us to do is a couple things. The first, it allows prototypal inheritance to work, because basically prototypal inheritance says, I'm an object, and I don't have a method, but I'm pointing to another object that has the method. I want you to call that method and pretend you're me. And what it does is it pretends that this is that object that called it from the outside, right? And likewise, it allows us to borrow behaviors without even a prototype relationship, right? And that's what we're doing here. We have object 1 that has a property called name and a method called speak that says my name is this name. We have an object 2 that just has a name property. We want to use that object 1's method without actually having it, right? Or without even actually pointing to a reference of it. And the syntax we use is we say, hey, object 1, call your method and pretend you're me. Now, most people from other languages go, that is pants on head stupid. Yeah.
You go back to the slide.
Sure.
So if you didn't pass object 2 in the call, then it would print my name is who?
If you did not provide a first argument, I believe it would, yeah.
So
I believe it would. I believe the default would be to look.
it's an anonymous interfunction speak, right?
Correct. But because we call it from this method, I believe even without specifying what this is, it will default, because it's been called from the method. It should default to that object who owns the method.
Can you skip like a legitimate use case
There are use cases. So for example, so if you have, if you're using a callback, right, and that callback might be used by multiple calling parties, right? Actually, this was part of that function.prototype.bind argument. I just had to feel it work. Hold on, I'm trying to remember the exact use case we had. It's generally when you have a callback that you want to invoke, right? And you don't know who has called the initial method, right? And in addition to that, you can pre-bind the callback results. I can probably find the code in the pull request after this. If you want to grab me and I'll show you. There are legit use cases for it though. Okay.
So, sorry, Tim, back here. A similar thing could be accomplished by creating object 2, using object 1 as a prototype, except for that.
Yes.
Permanently, that would be the case.
The only difference is at that point you're then creating a relationship between object 2 and object 1, which is the delegation pointer called the prototype, right? But still, object 2 wouldn't own or directly reference that method. It would just point to another object, and behind the scenes it uses essentially the same thing, where he pre-binds this argument when it's invoked. It's like calling function.call. All right, so here's, as I mentioned earlier, what people typically think of as the 3 kind of pillars of modern object-oriented programming. And we'll look at them one by one. So I mentioned that there's no access modifiers in JavaScript. By default, everything's public. Now, that's likely to change. There's some proposals in front of the TC39 committee right now to add private members and things like that. But for and you can do that in TypeScript, right? But for right now, everything's public. So there's a couple of strategies for achieving encapsulation. Classically, with previous versions of JavaScript, we've used closures and privilege methods within those closures. right? And then as of ES6, we have a brand new primitive type called symbols. And with the use of both a single closure and a symbol, you can actually achieve true privacy there as well. Let's look what those look like. You guys have probably seen something like this before. Everyone's familiar with getters and setters from ES5? A lot of people don't know about that either. So you can actually define now in an object literal or using that object.create syntax or object.define property syntax, you can define getter and setter functions that to the outside world just expose these as properties, right? Read-write properties. So here you would just, whatever gets returned, you'd do object.foo equals or tell me what object.foo is. And behind the scenes, it's going to execute this function. They'll let you do things like setting read-only properties that only have getters, right? Things like that. Or doing some sort of a transformative logic on either way, either the getter or the setter. But what you can do here, in this case, we're basically creating these getters. The setter, in particular, is a privileged method, right? Privileged methods. There's no direct access to the state that's encapsulated here. This is achieved by a closure, right? That's created by this function here. Because once this executes, right? Once this initial call, this immediate function, has finished executing, these functions here still retain access to this foo variable, which is here. Everyone's familiar with closures. Does anyone not know how a closure works? All right, good. We're all experts on closures. And so basically, we've closed over this foo variable here. Basically, what it does is it retains the execution context of this initial call, right, and holds the state of that foo variable. And in which case, then, from the outside world, we can manipulate this object just as if it had a property called foo. And what it's really doing is just calling these functions, and this guy is controlling the state. And that state is actually truly encapsulated, right? It's proper encapsulation, just without access modifiers. Here's another example. Instead of using getters and setters prior to ES5, we would have probably done something like this. This should be familiar with Java developers, right? Who have to have these really clunky get property name, set property name. Hate that. That's one thing I did appreciate about C#. C# was Microsoft's answer to Java, essentially. They basically took all the good things about Java and dumped a whole bunch of money into it and made something better. And evolved it a lot faster.
You no longer have to use return in JavaScript if you.
So the other thing, these are for those not familiar. This was that illustrious the arrow function syntax, right? Which was inspired by both CoffeeScript and C#, both of which have this, for Lambda expressions, have this implicit right-hand return. So the syntax here is, this is the function declaration here. This would be an anonymous function, right? Arrow functions are always function expressions. Yeah, they're always function expressions. There's no such thing as a function declaration with an arrow function. They're always function expressions, right? Which means they always return something. And the right-hand side is an implicit return. It's meant to be an expression. You wrap it in curly braces. If you want it to do something but not return. And if you want to return an object literal, you have to wrap that whole thing in parens, right? But in its simplest form, it's arguments, in this case none, and then implicit return.
So if you're doing a multi-line return, a function that returns, you're going to use the brackets.
If you're doing a multi-line, you'd have to have brackets, yeah, absolutely. Because otherwise the parser will see the end of line and think that that's the return.
You have to call return explicitly at the end.
Yes, yeah. But if it's just a simple expression on the right-hand side, it's an implicit return. So these are really useful for, they don't make sense everywhere, but they are great for like functional programming things, like the array processing utilities we got in ES5. They make, if you're doing a series of operations on array, like map, sort, reduce, things like that, they make the function expression size. It makes your code a lot easier to read. There's other reasons for them. I mentioned that they don't create a lexical this binding, so they're really good for methods inside a property, an object's methods. If you have, like, say, private functions that get called inside another method, you should limit those, right? Your function should be single purpose as much as possible, but they can be useful because they'll just reference this as the outside lexical code. So that's another way to do it, and thanks for pointing that out. I'm so used to the arrow function syntax now that I don't even notice it in code base.
But I didn't realize to use it this way.
It's a little, it's loose too, right? The syntax is loose. The parentheses are optional when there are no arguments, or when there's one or few, no, if there's one argument, the parentheses are optional. Otherwise, for no arguments, you have to have parentheses. For one, it's optional. For more than one, it's required. You probably should have just made parens required all the time. And so our code base says always use parens. Keep it consistent, right? Okay, so I mentioned symbols. Is everybody familiar with symbols in ES6? Who's not familiar with symbols? Okay, so symbols are the newest primitive type in JavaScript. The others being number, string, nan, undefined, and null. And so they're a primitive type. They're added to the language in ES6, and what they basically do is they give you a unique identifier. They're guaranteed to be unique within the executing context, and there's another syntax, and I don't recall it offhand. There's a great series called ECMAScript 6 in depth, part 1 through 3, by some guy named Tim Doherty. I can point you to that if you want to check it out. There is a way to actually make them global across an entire application's executing context as well. But basically, they're guaranteed to be unique. And what we're doing here, similar to the previous example, we have an immediately invoked function expression, which will create a closure for us, right? And that closure will hold the reference to the symbol. This is a curious thing. It is not a constructor. This is actually a method to create a new symbol. I'm not sure why they decided to capitalize it, except perhaps to indicate that it's a built-in type. But this will return you a new symbol, and we're going to hold that. We're going to close over it by referencing it in our constructor here. And so what this returns is this returns a new class definition. So this immediately invoked function expression only needs to be called once. We only create the closure once. We only close over that variable once. And that's an important thing about closures. Every time you create a closure, you're holding onto the execution context of the function that's being closed over. So they're great for like singletons and things like that. Something like this that returns a constructor. They're really bad for like object factories that create thousands of instances, because every time you call that function and create an instance, you're holding onto that execution context in memory. That's how you create memory leaks. Anyway, inside our constructor, we are creating so we want to create a property whose key is this unique identifier, and its value is whatever we passed in to instantiate the object. And then we're going to create a getter for it that has privileged access to that closed over variable to return the value. And this way we achieve true privacy. Right? The only thing that knows the value of that symbol is this factory that created that constructor. Make sense? Symbols are used internally by the language for things like, so we got, the other cool new thing we got in ES6 was iterators. And so we now have proper lazy iteration over collections in JavaScript. We don't need to know ahead of time the size of the collection in order to iterate it. We don't need to check its length. We can basically just say, do you have a next item? Okay, get it, great. Do you have a next item, right? We can then therefore lazily evaluate the list. And symbols are used to define that function that does the iteration, right? So internally, you define a property called the iterate. It's a reserved symbol called iterator. And that allows you then, it's basically a contract if you're creating an iterator on an object. You define a method whose key is a symbol, the special symbol iterator. And then it's used by the interpreter to recognize that. And there's a variety, if you check out the spec, there's a variety of other use cases that the actual implementers of JavaScript use. And then if you want to use symbols, this is a use case for them. There are others. Okay, inheritance. So JavaScript supports two distinct types of inheritance. And they are quite different than inheritance the way we think of them in a class-based object-oriented language. We don't actually extend the behavior of something by basically getting everything that it is as and adds things to it. Instead, we either point to things and say, I want to delegate behavior to you, or we copy it. And that's called concatenative inheritance. Mix-ins. Anyone familiar with mix-ins? That's a great example of concatenative inheritance. So we talked about prototypal inheritance, and we mentioned the prototype chain. And these are the rules, basically, of how it works, right? You create an object, you specify its prototype. At runtime, you request that object to do something, calls to invoke some method. And it says, do I have it? No. Okay. Do I have a prototype? Yes. Does the prototype have it? No. Does it have a prototype? Yes. Does it have the method? Yes. Cool. Bingo. Invoke it. Otherwise, you go all the way up the chain to object.prototype, An object.prototype has no prototype, so you'll throw a runtime error at that point saying whatever method you tried to call is undefined. There's a really super clear, simple example illustrating it visually for you. Everybody understands that, right? It's actually a pretty good diagram. This actually captures it pretty well. So this is what it looks like. And we sort of saw this briefly before. We saw just setting up the single object in its prototype. Here, we're actually creating another constructor and telling it that its prototype is an instance of this guy. Right? Because remember, a prototype is an object. Right? So we can't just tell it that the prototype is the constructor, because the constructor is just a function. But we have a prototype on this constructor. This is used to create new instances that have this as a prototype. And what we want to do is we want this guy to use a new one of these as its prototype, because it actually has to be an instance. It has to be an object. So we create a new object. We call its own method, right? Object.foo. We call the prototypes method. And then here, object.baz doesn't exist, so we're going to throw an error. The other type of inheritance is called concatenative inheritance. And this is a really important form of inheritance as well. This is basically the idea that you want to take two or more different things and create a new thing out of it, right? It enables real multiple inheritance. The good thing is it doesn't enable multiple inheritance the way C++ does, where you get that classic diamond problem, right? Where you have this core object, and you have two objects that inherit from that, and then you have one down here that inherits from both of those. Which one does it use, right? Which has actually been reintroduced in Java 8 with default interface methods. Anyone familiar with default interface methods? If you're interested in that, talk to me afterwards. It's kind of interesting. There's a legit use case for it, but it reintroduces that classic diamond problem. But basically what we get is we get to dynamically extend objects. It was first popularized probably by jQuery with the $.extend method. Underscore had a version of it. Angular has a version of it. A lot of popular utility libraries have this idea. And it is now supported natively in ES6 with object.assign. The caveat being that it only works with the object's own enumerable properties. It won't traverse the prototype chain. So if you need to do that, there's workarounds using object.assign, but it's great for simple, shallow copying. And it enables multiple inheritance. So this is what it looks like. You have object 1 with a method called foo, object 2 with a method called bar, and we're going to call object.assign, and it takes a source object, target object, source object 1, source object 2, source object ad infinitum, and it basically goes from right to left and copies them. And so properties get overridden. If there's duplicate properties along that chain of source items, the last one in wins. All right, polymorphism. Everyone knows what polymorphism is, right? I mean, one thing can mean different things depending on the context, essentially. So there's a couple of ways to achieve it. If we talk about overriding, everyone knows the difference between overriding and overloading, right? Does anyone not know the difference between overriding and overloading?
Yeah, I could use it.
Okay. Overriding means changing the implementation of a method, right? Downstream somewhere. Overloading means changing its signature such that it behaves different, so that you can have multiple versions of it on the same object, right? So overriding would be you define it on a base class, you inherit that class, and you swap out the implementation with a new one. Or some instances might just choose to use whatever they inherited. That's overriding. Overloading is I have method 1 that takes string argument, decimal argument, whatever, and then I have the same named method with different number or types of arguments, right, in a class-based or a strongly typed language.
You can't do that in JavaScript.
You can. It's just different, right? It's different. So let's talk about overriding first, right? There's a couple of different ways to do overriding, right? The first is if you have a prototype and it has that method, you can just replace it on your instance, right? You can inherit from that prototype and just you can replace the instance method at runtime after it's been created, right? You can just say, hey, I got this from the prototype, but now I've decided based on the execution conditions, some condition, right, based on the state of the application, I need a different implementation. I'm going to swap it. I'm going to borrow it from some other object, whatever, right? And then you can also extend the parent's methods. right? You can do it. There's a clunky syntax to do it in ES5 that we'll look at, and then ES6 introduces super in the class syntax. That basically is calling that same named parent method on the parent or somewhere up the prototype chain. All right, so overriding a method. We have this myObject constructor. It's got a prototype. The prototype has a method called foo. So without this, if we created a new yourObject, it would get this foo. But instead, when we initialize this guy, we're redefining that method. So at creation time, we're just going to replace it. Right? So we're still here telling it that its prototype is this guy's prototype. So this is the other nice thing that you get with object.create. Previously, we saw that we used the new keyword on that constructor. Here, you can just say, create me an object and use that guy's prototype. Optionally, you could also call that constructor, do constructor.call and pass it the new instance if you wanted to use any initialization code that was in here. But in this case, we're deciding that we want to inherit from this guy, and presumably there would be a richer implementation here. Otherwise, if all we're doing is replacing that guy's method, it doesn't really make sense. This is obviously a contrived example, but one select method out of these, we're saying at instantiation time, ahead of time, at compile time, we know that we want to replace this method. Any questions on that? Pretty straightforward, right? Okay. Optionally, you could do what I mentioned earlier, which was to just override it at runtime, right? In other words, here we have this object, we create it, and then something changes. Some condition in our program says, you know what, can't use that instance. This instance doesn't use the default implementation anymore. Just replace it. It's a dynamic language. You can add, remove, change properties and methods at runtime. Just swap it out with whatever you want, right? And then the last way to do it is to extend a parent's method. So we've got our myObject. Its prototype has a function called bar. We want to create something that's going to have that guy as a prototype, but we want to extend that bar function. We want to do something different with it, right? We want to use it, we want to call it, but we want to add something to it. So what we do is we redefine the bar function inside this guy's initialization function, its constructor, and we tell it to use the default implementation. And here we use function.call and pass it the current instance. So we say, call this guy's constructor, or call this guy's function bar, and pretend you're me, and add my instance variable, my instance member called Baz. Like I said, it's kind of clunky. It doesn't really, and here, again, we're using the constructor. We want to initialize it here. There's really no reason to do this, because, well, I guess we do. We have this.foo here. So that lets us get the foo, right? Calling this guy's constructor and pretending that it's us. And then we get foobar. Any questions on that one? It's clunky. That syntax is clunky. This is one thing that is nice about the class syntax that we're going to see on the next slide. But does everyone understand that first? Anyone not understand that? Cool. So we did it with the class syntax. Again, we have our constructor. This was just like that function myObject. We define a prototype method on it. And then here, inside our constructor, we call super. This super calls the constructor, right? We set our instance member here to be bar. And then here we set our prototype and we tell it we want to call the super, the parent's bar method, and then add Baz. It's a little cleaner that way. Yeah, really great. Like I said, I actually like the concise. I just wish they could have called it something other than class. And I think that's a pretty decent sentiment out there, although there are those who feel very strongly that constructors, and that you should never use them. Eric Elliott is one of them. If you want to go check out some really opinionated JavaScript advice, check out a guy named Eric Elliott. He's a super smart guy, and he came from a background of other languages, like I did with C# and others. But he's a really smart guy, and he's got some very strong opinions. He thinks classes are evil. He thinks constructors are evil. And he's got some merits to those arguments. Worth checking out.
Everything should be spun up with like object.create.
Object.create, yeah, factories. Yeah, stamping things out. You can still use prototypes, right? But the main thrust of the argument, and it makes some sense, is that constructors couple instantiation with initialization of objects, right? Which means that at some later point, somewhere else in your code, you may not need that initial or want that initialization logic. You just want an instance, right? So there's some merit to it. But
sorry, on that point, like memory-wise, what is the best? I don't know if you know, what is the best way of defining an object? because I've been like told that like, but I don't know if it's true or like common knowledge that like you have like a prototype method versus like the method defined within the object or class, then every time you make, you won't be making the same function.
Yes, it is less expensive to borrow methods on the prototype because you only have the single function definition in memory, right, which is a few bytes probably, versus attaching them to every instance where those few bytes are multiplied by however many instances you have. However, and I'm glad you brought that up because this is an interesting topic, and it's a point of contention with lots of developers these days, whether JavaScript or otherwise. And that is issues of performance versus code readability and versus an understandable code base. We are in a very luxurious time as developers that memory is cheap, bandwidth is cheap, storage is cheap, hardware is cheap, right? And so to a certain extent, just in much the same way that we've been able to leverage frameworks to abstract us from the low-level plumbing that we used to have to do. You know, I'm old enough to remember the days when I used to carry around a utility library of, you know, string functions and array functions and stuff like that, right? Sort functions from job to job because you didn't really have a lot of choice in frameworks to do that kind of stuff for you. Much that we have that luxury today where, you know, application development is getting much larger scale. The scope of the problems you're having to solve are larger, and therefore that sort of low-level plumbing is largely abstracted unless you're dealing with performance-critical code. Because we now have cheap memory, cheap bandwidth, cheap hardware, cheap storage, most of the time, if you're struggling with performance optimization when you're initially writing your code, you're struggling with the wrong things. It's called premature optimization. If you can prove via real-world usage of your code that some portion of it is a bottleneck, then it's time to go in. I mean, you know, that doesn't mean you should just be sloppy, right? And write memory lakes, right? And just exorbitantly use resources. But it means that most of the things that people quibble over, as far as performance optimizations, are totally meaningless. Totally meaningless. Absolutely meaningless. That's the other argument I got into something about function.bind. Yes, it's probably not a good idea to use it in a loop, but even if you did, unless you're dealing with an enormous set of data, your processor is probably more, even the processor on this is probably more than capable of dealing with that in-memory data set without any problems, right? You're more likely to run into problems with network latency than you are with in-memory computation, unless you're dealing with a huge amount of data or performance-critical code. If you're writing games, then every byte counts, and you better be very careful with your memory. If you're writing a web application or a native application for mobile, probably not as much, right? That's a great topic of contention with the array methods that were introduced in ES5, right? Array.forEach, array.map, things like that. And it's true that a for loop is faster, right? If you do a for loop, especially if you cache the length of the array ahead of time in JavaScript, it's faster. Definitely is. You can prove that. It's really easy to strip away the cruft, get down to the basis of the problem, put it through a JS perf test, and you can see that a for loop is faster than array.forEach. However, array.forEach is a lot easier to read. It's a lot cleaner. It produces cleaner and more readable code. And unless you're dealing with a huge amount of data, massive arrays, if you submit a PR in my company with a for loop instead of for each, I'm probably going to ask you for a really good reason why you did it, or I'm going to decline it. It doesn't make sense. We can use the abstractions these days 99% of the time without worrying about the performance of it. So, but that's an excellent question. And the answer is prototype methods will always be more performant, but in reality, it probably doesn't matter. Unless you're designing a massive online multiplayer game where that constructor is responsible for creating bots and you have hundreds of millions of people playing it, probably doesn't matter.
Well, in my specific cases, like I'm doing like neural networks based on JavaScript. So basically, you have to create like little objects that or like subscribe to like a timer, like a weather call, right? So in that case, like everything is time locked. So basically, you're like talking about like say like 20 milliseconds. You have to be within that range. So it's not only about like how many you're going to create. It's like how much time lag they're going to introduce. So I mean that's more like the.
So in that case, you actually might be better having instance methods. If your question is how fast does property and method access happen, how fast does it need to happen, then it's going to almost always be faster if the method is local to the instance, because you're going to incur overhead traversing the prototype chain. Right? Prototype chains will save you in memory footprint because the method's only defined once. But the deeper the prototype chain is, the longer the runtime has to traverse the chain and find where the method lives. And if you have lots of instances out there that are all trying to traverse that prototype chain, particularly if the hierarchy is more than 2 or 3 deep, then it does get expensive. But we all know you should never design an inheritance hierarchy that's more than 2 or 3 levels deep, because the cognitive overhead of managing that is beyond most humans. It's really hard to, I've looked at code bases, we have them at work, Java code bases that are 5 and 6 levels deep. And man, just even with today's IDEs that will help you jump through that chain, it's hard to keep all that in your head. It's really hard. Don't do it. It's not a good idea. Yeah.
Does relying on the prototype also introduce thread safety issues?
Great thing about JavaScript, you never have to worry about thread safety. Why? Because all JavaScript environments, all mainstream JavaScript environments are single-threaded. There are some experiments right now. IBM's got one. I think, don't quote me on this, but I think it's called River Trail, where they're experimenting with concurrency and having two or more threads at the same time. But browsers and Node, are single-threaded. So the way Node does, Node actually is a JavaScript environment. However, 20-odd% of its subsystems are written in C and C++, and then it manages a thread pool. And that thread pool delegates tasks off to other plugins and extensions that are written also in C and C++. So that's how it interfaces with the operating system. But the actual Node the main event loop, that's a single C routine, and it's a single thread. And all it is just a big loop. It's a loop of, it's running in a loop, right? And to that loop, you attach functions, which are callbacks. And those callbacks are a few bytes a piece. I mean, if you have a really big one, it might be a couple hundred bytes, something like that, right? But they're cheap. And what happens is the event loop just keeps polling and looking to see whether or not one of those functions has been identified as the callback target of something else in the thread pool that it's managing. So a request comes in from the outside, and it says, "Ooh, I've got a callback for that request event that happened. Handle it," right? And inside that, it might say, do something with the file system library that Node provides, which is a subroutine written in C++. The event loop then hands that request off and holds the callback in memory, a few bytes, to say, this is the memory location, memory register that you should call when you're done. It goes off, it spawns off a thread, that thread does its thing. Meanwhile, the event loop's still spinning, waiting for the next request to come in, right? So the beauty of that, and the other one that does, the other web server that does that is Nginx, which is also an event loop. The beauty of that system is, as long as you don't bog down that event loop with computationally intensive operations, it's incredibly fast, right? Because that event loop just keeps spinning. And at most, it's just got these small, couple bytes memory registers to holding that callback. And it just says, something comes in, cool, hand it off. Something comes in, cool, hand it, oh, something's ready, hand it back out, right? And so it can be massively concurrent. It's super efficient. It just gets misused when people try and do like Fibonacci sequences or stupid computational stuff in the event loop itself. And if you use it right, it's highly scalable. It's a really interesting idea. But the point being is JavaScript is single-threaded. You never have to worry about thread safety. Probably the best equivalent in terms of dealing with complexity, because that's one of the good tests, right? When you get to like a senior engineer level, is dealing with multi-threading. It's hard, right? Multi-threaded programming is really hard. Even with all the stuff that modern languages give you to deal with it, it's hard, right? The closest you get to that in JavaScript is dealing with asynchrony, right? Dealing with asynchronous events, and especially when you have to coordinate asynchronous events. But I would argue it's still not as hard as multi-threaded programming. But there's no thread safety.
Aren't web workers kind of exception to that?
Well, no, because web workers are a different process, right? Web workers run in their own thread. The inter-channel communication is just simple messaging. You get to send a message to the web worker and it can send a message back, but there's no shared memory. That's being introduced though. There's a proposal for, 2017 for shared memory. so that a web worker and the main rendering thread can then communicate by updating that shared memory. And in which case, you will start getting into multi-threaded issues. But in today's world, a web worker is just, you spawn one up, you tell it to do something, and you can pass messages back and forth. But you're never in contention for the same memory or the same resources. So it's not multi-threaded in the way we think of like a multi-threaded Java application where you have contention for the same space in memory. The same variable could be overwritten or the same database record could be updated at the same time. You're never contending for that. Web workers are really cool though. The other really cool thing that I haven't had a chance to play with yet is service workers. You guys familiar with service workers? What's that? Yeah, it's experimental. It's not mainstream into the browsers yet. Service workers are sort of like web workers, only the idea is that they can maintain persistent storage. They're intended to act like a smart caching proxy between an application, web application. They're primarily designed for mobile, where you can prefetch data and stage data and persist things in between sessions. And the idea is to reduce the latency required by mobile web applications at startup, where they can pull all the state that was previously used from the storage that service worker has in its own local storage or its IndexedDB collection or whatever it uses to persist it, and start the app up immediately, and in a separate thread go off and make all those requests that it needs to refresh the data, do the login, the authentication, pull new data down, and as soon as it's ready, it passes it back to that main thread. It's a really good idea, and I think it's one of the things that has prevented mobile web apps from kind of displacing native apps. I think we've gone off the rails a little bit with the native apps. With this discussion in general. And so I'll wrap it up because I do have a few things that I want to cover yet, and we have to be out here at 8:30. We went from the world of deploying CDs, right, and hard physical media onto devices, and all the pain that went with updating that. I spent a couple of years writing install shield scripts, and let me tell you, man, that is a pain in the ass. Just the permutations of all the deployment targets and accounting for that, it's a nightmare. And then we evolved to client server, and then we evolved to smart web applications, and we reached this kind of utopia for developers where you could instantly update all of your users in one go, right? It's amazing, awesome. Like web apps are great for that, right? And then we took this massive step backwards to native applications for mobile, where we have all the same problems that we had with, we have better deployment channels now, but ultimately you still have to get someone to install your app. The amount of advertising money that's spent just to get to someone to look at your app in the App Store, let alone install it, is absurd, man. It's obscene. And then you have to get them to update it and all this stuff like that, right? And I think the reason why apps have done so well is because the web experience hasn't been able to bridge those performance, or at least perceived performance gaps. And that's been narrowing and narrowing and narrowing. And I think service workers might just be the nail in the coffin that finally pushes them over to that performance threshold where we could start seeing the great utopian world of deploy once, and it's in everyone's hands again.
With iOS, it's gotten a lot harder to keep people from updating, like to keep from updating your apps.
Sure, yeah, they do it automatically.
Wants to do it.
Okay, so now let's talk about overloading. We saw overriding. Now let's talk about overloading. Well, it turns out that overloading is incredibly easy in JavaScript because types aren't checked, right? We have duck typing, and there's no static type checking. And you can have a variable number of arguments to a function. So you can literally just define your function with 0 arguments if you wanted to. In this case, we're illustrating it with a contrived example where we have 2. But you could literally just define it with 0 and pass it as many as you want. And we have this wonderful little built-in thing called arguments, which is deprecated and eventually will go away. But for now, we can use it. And it's an array-like object that contains all the arguments that were passed in. And so you can do conditional behavior depending on the length and number of arguments that were passed in and stuff like that. You can even do simple type checking on the arguments as well. There's much better ways to do this now. In ES6, you have default arguments. And those default arguments can use destructuring as well. So you can actually define an object that represents the named parameters and the type, not really the types, but the named parameters you'd like to pass in and default values for them. And you can get a lot more sophisticated than this. But this is the simplest example where we got 2 arguments. If we have 1 argument, do something. If we have 2 arguments, do something else. But you could have as many arguments as you want. Arguments, as I said, has been deprecated. We now have a really cool syntax enhancement called the spread operator, which is ... And they usually call it rest in that case. It's the same operator, but it has two things. It'll either spread things out or gather them together. In this case, when it's rest, it gathers them together. So you could have like a list of named arguments you expect, and the last one could be a variable number of arrays, and or number of arguments. You go ... rest arguments, and it's an actual array that comes in. It's nice. It's actually a really nice syntax enhancement. All right, so let's wrap it up. Let's compare the two, prototypal versus classical OOP. In a nutshell, the best metaphor I've seen yet is by a guy named Reginald Braithwaite, who's an author and speaker out there on the circuit. He wrote a book called JavaScript Allongé, which is about functional programming in JavaScript, which is a really good read. But he's got some really good blog posts out there and books and things that are worth reading. And I borrowed this metaphor from him, and I think it's pretty apt. It breaks down, but the general high-level metaphor is pretty good, which is basically a prototype is like a model home, right? It's generally kept empty. Nobody lives in it, but you could. It's a fully functioning house. It is a model of the rest of the homes in that tract. If you wanted to, you could move your family in there, right? Fully functional home. The metaphor breaks down when you modify the prototype, because if you modify that model home, all the other homes that have been built in the tract don't all of a sudden get a new deck, right? So that breaks down, but the initial idea is a pretty solid metaphor. A class is more like a blueprint. It tells you exactly how to build that home, but you can't live in it, right? And likewise, a prototype's an object. You can use it in your program. But a class, you can't use a class directly. Well, you can use static methods on the class typically, but the class itself is just this template. It's a blueprint. In prototypal OO, you use behavior delegation instead of real inheritance. You never actually really inherit something in prototypal languages. You just point at other things. You act like you inherited it, but you really don't. It's like using your uncle's Ferrari instead of him giving it to you, right? So in prototype-based languages, that's all you do. You delegate behavior, right? I don't have the behavior myself. You do it for me, pretend you're me, right? It's pretty much all it is. The only linkage between those two objects is the pointer. And in JavaScript or other prototype-based languages, we call that pointer a prototype. It's just a name we use for it, right? And so it can use those behaviors without actually owning them in memory or even directly pointing to them. All it does is point at that object, right? That's it. In a class-based language, in most class-based languages, inheritance is achieved by extending existing classes, which means that that child object has to be similar to its parent, right? By the very virtue of it extending everything that it has to have a similar memory footprint, right? It kind of has to look like it. It can enhance it, but at its base, it gets everything the parent got. Right? And it either directly owns or directly references, points to in memory the methods of its parent. So this sort of frees you up from a memory perspective and from a structural perspective. And then late versus early binding is kind of the last major difference. So in prototypal OO, it supports Dr. K's criteria, extreme late binding, right? You can have a bunch of instances out there that have been running, and then you can modify the prototype and they all get that change, right? That's the very definition of extreme late binding, right? That behavior is not bound during compile time. It's bound as soon as it's needed, right? Anytime in the runtime. In most class-based languages, early binding is enforced, right? In other words, typically at instantiation time, the runtime needs, so the compiler knows ahead of time, and it's certainly at runtime. So for example, if you're using interfaces and you're not sure what the actual implementation is until it's instantiated, still when the object is created, its behavior is typically bound at that point. So to wrap it up, JavaScript is a minimalist language in general, but its idea of objects is pretty simple. Right? It's evolving. The fear is that the committee will eventually change JavaScript into Java, and Angular will help them do that. I had a funny interface with the Angular team at Fluent last year, and sort of criticizing them on how Java-esque Angular is. And I asked them if they were, if pushing TypeScript in there it's kind of part of it, because they're heavily influenced. They're a big Java shop, right, at Google. And if you look at especially Angular 1, if you look at how it's written, if you've gone and looked at the source code, but even the constructs that they expose, the dependency injector, all that stuff, it's obviously heavily influenced by Java. Those guys were Java developers who wrote a JavaScript framework, and they did a lot of stuff right. But they overthought it, and that's been one of the major complaints about Angular 1 is that it's too complex, right? The learning curve is very steep. And I would argue that Angular 2 didn't do a whole lot to dispel that. In fact, they made it even more clunky.
Angular 2, like, I mean, correct me if I'm wrong, but like, even though it depends on TypeScript, right? So,
No. They wrote it in TypeScript. And TypeScript is the default preferred language, but you can write it in vanilla ES5 if you want. And one of my complaints about it is, in choosing TypeScript as the default language, it means that all the blog posts, all the examples, all the documentation, and 90% of the code bases out there are going to be TypeScript. So that even though you can write it in ES6 or ES5, if you're going to learn Angular, you're going to find all the examples in TypeScript. In fact, if you go to the documentation on the site, it's improved, but like when I was first playing around with it, the documentation was incomplete. They had pretty much all the documentation, or most of it, was written already for TypeScript. And then they had 80% of it written for Dart, and a little bit for ES5. And I was like, ES6, anyone? Like a lot of us are using that. Can we have some examples in ES6? Anyway, I digress. If you want to talk to me about Angular 2 afterwards, I'll provide copious opinions on what I think of it. No, it's good. There's a lot of good stuff in there. I just think it's not what the Google team promised us when they told us they were going to rewrite Angular and address a lot of the concerns around complexity. Anyway, JavaScript's prototype-based language. It's not the only one out there, but it's probably the only one that the average developer knows. There's just a handful of them. It supports the main 3 pillars of what we consider to be object-oriented programming these days. It supports 2 different types of inheritance, although, like I said, they're not. Concatenative inheritance is kind of more like inheritance, where you copy stuff from other things. You actually do get them. Prototype inheritance really isn't inheritance, in my opinion. And it's considerably different from class-based languages. Even though class-based OO is mainstream, I hope I've made an argument that JavaScript is an object-oriented language. Right? It just approaches the idea of objects and object messaging and object inheritance differently than mainstream classical OO languages. And I got some resources here for you. I'll post this slide deck up for you. It's actually on Google Docs, so I'll share it with the group. These are some people that I follow who I think all these guys do a really good job. The other guy that I probably should have included here that I also really appreciate his writing style is Nick Zakis, he used to be at AOL for a long time. And he's got a really good book on ES6 as well. He's also a really good writer. Axel Rauschmeier is great because he's, so there's different perspectives here. If you want to learn how to use the stuff, go with people like Eric Elliott, because he's very much geared to getting you actually up and running with the language. If you want to know how the language works, most of these guys are better, particularly Axel Rauschmeier and Kyle Simpson. Those guys are really good for getting deep into actually the specifics of the language. And then this last one here, and he actually just rewrote a new version of this with ES6 in it, by Myron Haverbeck. That's just a fantastic introduction to programming, JavaScript or otherwise. He's such an eloquent writer. I mean, it really is an incredibly well-written book that takes you step by step through, the paradigms of programming, illustrating using JavaScript. It's one of the best programming books out there, I think, but especially for people who are getting started. And Eloquent JavaScript, yeah. Great book, highly recommend it. And with that, that's all I got. 8:25, we're still under time. Any questions?
So why they go for the prototypal inheritance versus just the classical?
You'd have to ask Brendan Eich that, who wrote it. It's a really good question, and people have been asking him it for 20 years.
Does some of that have to do with
No, I don't think so. I mean, while it was originally launched in the browser, it has become, almost exclusively a browser-based language until Node came around. There have been a few attempts at server-side. It was originally intended to run on Netscape's servers as a server-side scripting language, but it never saw fruition. So it's an excellent question. Lots of people have asked that. The mainstream, the popular view is that prototypal inheritance is really bad and stupid. But those of us who use it see merit in it. And, Brendan Eich's a pretty smart guy. I mean, he was writing compilers at the time. He knows his stuff, and he had to have had solid reasons to do it. He claims to have been influenced by Scheme, which is another prototype-based language. I don't know a whole lot about it, so I'm not going to make uninformed opinions on it. But go check it out. He claims to have been mostly influenced by Scheme and Lisp. But good question. Okay, well, I have a question for you guys. Who's going to speak at our next couple of meetups? Because we have no speakers. In fact, it looks as if our next event may need to be canceled because both Garvin and I are going to be out of town. Unless somebody else wants to step up and run a meetup for one night, we may have to take a break on the February meetup. But that leaves March open. So I submitted a couple of talks for Fluent this year, and I'll hear back in February whether any of them were accepted. And if they were, I'm more than happy to work on those talks and do a dry run here. Meanwhile, this is your meetup, guys, and the way it gets great is if you stand where I'm standing and speak to the rest of the group about JavaScript. That's how we do this thing. And I'm going to keep putting out feelers. I've been putting out feelers to the JSLA group. I got a few interested parties, but nobody's really followed up yet. What might be really kind of cool is maybe we create a position for a speaker getter on our little committee here and have someone who's kind of respond. And that's like not a huge job, but it's something that somebody could kind of take and run with and, you know, chat with the people in town and anyone else they know that, I mean, my employer, Agilicis, has agreed to, you know, like pay gas for people driving up from LA or somewhere, you know, within a reasonable distance and maybe even a hotel for the night if it's a long drive. So that kind of expands our boundaries a little bit. It'd be really nice to get some people from out of town. But anyway, we need speakers and us to do better for this group. Let us know. See me or Garvin, hit us up on Meetup, hit us up on Twitter. And then I think these guys have an event they're going to start kicking off. I think John wanted to get up and say a couple words about that. So take it away, man.
So I'm John Lawrence. I run Learn to Code Meetup with Dylan Ernst, who's mostly